Hello everyone, my name is Fayyaz Makhani and I've been a long-time technologist and researcher. I'm a global security architect at Viking Cloud where I help build products and services using artificial intelligence. Today, we'll take an overview of artificial intelligence and AI vulnerabilities. Artificial intelligence has undoubtedly revolutionized numerous industries and has brought significant advancements. However, like any technology, AI is not immune to vulnerabilities. We'll explore what AI vulnerabilities mean in the context of machine learning and deep learning systems. Understanding these vulnerabilities is essential to managing the risks associated with AI implementations and the potential for misuse or exploitation. AI vulnerabilities can have far-reaching consequences, from misleading AI-generated content to privacy violations and discriminatory decision-making. These vulnerabilities pose significant risks. We will analyze hypothetical case studies to understand these impacts. Mitigating AI vulnerabilities is crucial to maintaining the trust and reliability of AI systems. We'll discuss several strategies and best practices for that. AI does not live in isolation. It's connected to sensors, to IoT, to data inputs, computing infrastructure, applications, all of which expand the attack surface for the target. As we discuss the vulnerabilities related specifically to AIs in this discussion, the security of the ecosystem in which these AIs live cannot be overstated. The consequences of AI vulnerabilities can extend beyond the realm of technology and affect real-world scenarios. Imagine a scenario where autonomous vehicles or medical AI systems are compromised due to vulnerabilities. To mitigate these risks, a security-first mindset is needed. Robust testing and validation processes during AI development can help identify and address these vulnerabilities before deployment. Additionally, continuous monitoring and feedback loops can detect anomalies or potential attacks in real time. AI vulnerabilities fall into various categories or types. They include adversarial attacks, data poisoning, model inversion, privacy breaches, and bias and fairness issues. Let's start with adversarial attacks. Adversarial attacks are one of the most well-known and well-researched vulnerabilities in AI systems. In adversarial attacks, attackers deliberately introduce small and imperceptible changes to the input data of an AI model to cause it to misclassify or to make incorrect decisions. The consequences of adversarial attacks can be severe, especially in safety-critical applications such as autonomous vehicles or medical diagnosis. Imagine a self-driving car misidentifying a stop sign or a medical AI misdiagnosing a life-threatening condition due to these adversarial inputs. To mitigate adversarial attacks, we can employ adversarial training techniques. By exposing AI models to adversarial examples during the training process, the model becomes more robust and resilient to such attacks. Additionally, employing safety mechanisms and defense mechanisms like input perturbations and model ensembling can help enhance the model's security. Data poisoning involves attackers intentionally injecting malicious or misleading data into the training data set to manipulate the AI model's behavior. The poisoned data may be crafted to introduce biases or to exploit vulnerabilities, leading to skewed model outcomes. Unlike adversarial attacks, which modify inputs during the inference phase, data poisoning attacks target the AI system's training phase. Utilizing a data poisoning attack, attackers can manipulate product ratings to promote or demote certain products. To address data poisoning, robust data validation and sanitization techniques are necessary during the data pre-processing stage. Employing outlier detection and data integrity checks can help identify and remove these poisoned data from the training set. Additionally, using diverse and representative data sets can reduce the impact of targeted attacks. Moving on to model inversion attacks, these involve adversaries trying to extract sensitive information or insights from the model's output. By inputting carefully crafted queries and observing the model's responses, attackers can infer details about the training data or about individual users. Model inversion attacks can lead to privacy breaches and data leakage, especially in applications where AI models handle sensitive information such as medical records or financial data. Mitigation against these model inversion threats utilize privacy-preserving techniques like differential privacy or secure multi-party computation. AI models learn from the data they're trained on, and if the training data is biased, the models can perpetuate and amplify these biases. Bias and fairness issues in AI can lead to discriminatory outcomes, reinforcing these social inequalities. Examples of bias in AI include racial or gender bias in facial recognition systems, leading to misidentification and sometimes unjust treatments of certain demographics. To promote fairness and mitigate this bias, AI developers should carefully curate and evaluate their training data. Additionally, employing debiasing techniques during the training can help reduce these biased behaviors in AI models. Ensuring diverse representation in the development teams and involving ethicists can also aid in identifying and rectifying bias in AI systems. AI content, such as deepfakes, text generation, and image manipulation, can be misleading and lead to misinformation. Adversarial attacks and data poisoning can be used to craft convincing fake content that is indistinguishable from authentic information. AI systems that suffer from adversarial attacks or model inversion vulnerabilities can make incorrect decisions that have real-world consequences. In critical domains like healthcare, finance, autonomous vehicles, compromised decision-making can lead to life-threatening situations and financial losses. AI systems may unintentionally store or reveal sensitive data, especially when facing poisoning or model inversion attacks. Privacy violations and data breaches can have severe consequences for both individuals and organizations, leading to reputational damage and legal liabilities. AI vulnerabilities can result in legal and ethical implications, especially when bias and fairness issues come into play. Discriminatory AI decisions and biased outcomes can lead to violations of anti-discrimination laws and ethical guidelines. Let's explore a not-so-hypothetical scenario. A facility has implemented an AI-based facial recognition system for access control. That system relies on a deep learning neural network trained on a large data set of facial images. The attackers aiming to bypass the facial recognition system undetected initiate an adversarial attack. First, the attackers study the decision boundaries of facial recognition models, which define how these models categorize different facial features. By understanding these decision boundaries, especially in the target models, the attackers can create images that exploit these models' characteristics. Next, the attacker will create an adversarial image by introducing subtle perturbations into the facial features of individuals. These perturbations are calculated to be nearly imperceptible to the human eye, but significantly alter the model's predictions. The attackers repeatedly test these adversarial images on facial recognition systems and iteratively refining the adversarial perturbations and improving these images. Eventually, the adversarial images are able to deceive the facial recognition system in granting unauthorized access. So how do we mitigate this? We mitigate this by employing adversarial training during the AI model's development. By training the model on both clean and adversarial examples during the training, the model becomes more resilient to adversarial attacks during deployment. We can also mitigate this by applying pre-processing techniques such as input normalization and randomization. We can also leverage ensemble methods by combining multiple outputs of multiple AI models. Ensembles can detect and reject adversarial models more effectively, enhancing the system's overall robustness. And finally, we can implement continuous model monitoring and feedback loops during the real-world deployment. We need to regularly analyze the model's outputs to detect potential adversarial behavior, triggering these countermeasures or human intervention when necessary. Let's look at another scenario. Consider an online social e-commerce platform that employs an AI recommendation system to suggest personalized contents to its users. The recommendation system analyzes users' viewing histories, preferences, and interactions to deliver tailored content recommendations. So where can an attacker go from here? The attackers identify the recommendation system as a potential target for data poisoning. They create multiple fake user accounts and intentionally interact with a wide range of unrelated or irrelevant content on the platform. These fake interactions are designed to confuse and mislead the AI recommendation system by introducing bias and noise into the training data. As the recommendation system continuously learns and updates its model based on user interactions, the presence of this poison data starts influencing the model's understanding of users' preferences and content relevance. Over time, the poison data increasingly skews the system's recommendation, causing it to suggest irrelevant or worse, inappropriate content to genuine users. As the recommendation system becomes tainted with poison data, its suggestions become less accurate and less relevant to users. Users may receive content recommendations that are unrelated or objectionable, leading to frustration and dissatisfaction. Mitigation here can start with user behavior analysis to detect and identify suspicious user activities that might indicate data poisoning attempts. Deviations from normal user patterns can serve as early warning signs of potential data poisoning. We can also establish mechanisms for data verification and validation to ensure the authenticity and accuracy of user interactions. This may involve email verification, phone number verification, or CAPTCHA challenges. Third, we can utilize anomaly detection to identify unusual patterns in user interactions and content consumption. AI models can be trained to detect outliers and anomalies, helping to flag potentially poisoned data. And finally, reinforcement learning can help the system learn and adapt based on user feedback, making it more resilient to data poisoning attempts. What are some best practices in this area? Let's start with a risk assessment. A comprehensive risk assessment is a fundamental first step in the AI implementation process. Before deploying an AI system, conduct a thorough risk and vulnerability assessment, including security, privacy, and bias and fairness risks that may arise during the system's lifecycle. Let me start. A comprehensive risk assessment is a fundamental first step in AI implementation process. Before deploying an AI system, conduct a thorough risk and vulnerability assessment, including security, privacy, and bias and fairness risks that may arise during the system's entire lifecycle. As AI systems are dynamic and continuously evolving, as a result, vulnerabilities may emerge over time due to changes in the operating environment or new attack techniques. To maintain the security and reliability of AI systems, regular updates and patches are necessary. Regular updates should include model retraining using the latest data so that the AI system remains accurate and up to date. Regular updates should also include integration of newly developed mitigation strategies to counter these emerging threats. Implementing AI systems that are secure, ethical, and unbiased requires expertise in diverse fields. Collaboration with experts extends to interdisciplinary teams, including legal experts, data scientists, and domain specialists, to ensure that AI implementations are aligned with legal and industry regulations and specific use cases from today. The first key takeaway is that What are some key points from today? The first key takeaway is that AI vulnerabilities are real-world. The first key takeaway is that AI vulnerabilities are real and should not be underestimated. AI systems, like any technology, are susceptible to various risks and weaknesses. Adversarial attacks, data poisoning, model inversion, privacy breaches, and bias and fairness issues are just some of the vulnerabilities that can threaten the integrity and reliability of AI implementations. We need a comprehensive understanding of the different types of vulnerabilities that AI systems face. Each type of vulnerability requires distinct mitigation strategies and defense mechanisms. For instance, adversarial attacks demand adversarial training and robust input validation, while data poisoning needs thorough data validation and sanitization. A deep understanding of this allows us to tailor our mitigation efforts to develop a holistic approach to address these challenges. And remember, mitigation is not a one-time effort, but an ongoing process that requires continuous monitoring, regular updates, and collaboration with experts in AI security and ethics. And with that, I'd like to thank you for your time today.